Okay, so last time we were doing section 2.2. We were partway through that, so we'll pretty much just start with an example right away. I really don't think there's anything we need to explain to get into it. So this problem, it's going to be about which is the company? They have fixed costs and variable costs. So what that basically means is like a variable cost changes, maybe depending on like how much of something you produce. So the more you produce, you have to pay like maybe 10 cents for each thing you make. Versus a fixed cost, maybe the person running the machine, they just get paid $50,000 a year to run the machine. Doesn't matter how many parts the machine produces. All right. So in our example, this company has fixed costs of $200,000. So that could be like the salary. Maybe they pay $200,000 to the employees. And they're making t-shirts, and it's $1.50 per shirt. So that's the cost for the company to make the shirt, and then they turn around and sell the shirt for $4. So there's a difference between what it costs them, what they sell it for, and then what their profit is. All those things are different. So we've got their cost, we've got what they sell it for. We could easily figure out the profit just by subtracting the two. Okay, so we're going to make two graphs. Okay, the first graph is going to represent the company's costs, and the second graph is going to represent their revenue. Now remember, revenue isn't necessarily profit. Revenue is just money that they take in. Cost is money they spend out to make the product. Okay, so let's see if we can come up with an equation for cost. What's going to be the variable here? What's the one thing that will change the cost or their revenue? So the 200,000 is fixed, but the number of what? Yeah, shirts. So the number of shirts that they make, that's going to be the variable. So we have to pick a variable. You just use S. So we're going to find cost as a function of how many shirts they make. And then we'll find the revenue as a function of how many shirts they make. All right, so let's scroll back up. Cost is $1.50 per shirt. So what would be the formula for the total cost? Yes, yeah, go ahead.
$1.50 times X, I guess.
Yeah, $1.50 times, what's our variable?
S or C? X.
X, yeah. So there's the cost. And what would be the revenue? How much money they take in per shirt? What would be the formula for that? How about Nathan?
Revenue they take in?
Mm-hmm.
That would be the minus what it costs.
Not profit yet.
No, not profit.
Not profit. Just the money that they take in.
Oh, so it's like 200,000 times that, right?
200,000 is money they spend out because that's a cost. All right. So actually, did we add that? So we'll come back to that in a second, but we need to add that in here too.
So it's times 4, whatever they.
4x. So when I did the cost, I only did the cost to make the shirts. I forgot to put the cost for the fixed cost, which is salary. You don't pay this cost over and over. You only pay 200,000 one time. Doesn't matter how many shirts you make. Okay. So there's our equations. Now it says find complete graphs. Okay, let's graph them. Natalie, what's the Y-intercept in the cost equation?
200,000.
Yeah, so I got to set my Y max at least at 200,000 so I can see it. So let's do that. X is the number of shirts we sell. So we're not going to sell negative shirts. How many shirts are we going to sell? I don't know. Let's go up to 8,000 shirts. Y is costs, or it could be revenue, depends on which graph you're looking at. Either way, your cost is not negative and your revenue is not negative. Your profit might be negative, but not your cost or revenue. And we got to go up to at least 200,000. I'd say we just go to 400,000. Hit graph. All right, so there's our cost. There's our revenue. Would you say that's a complete graph? What's not on the screen that I should probably be able to see? Yeah.
Or where they cross.
Yeah, where they intersect. So selling 8,000 shirts, it's not going to do it. Let's try selling 50,000 shirts. Still not sure that's going to quite. No. So let's try 100,000 shirts. Okay, I think that should probably get it on the screen. Yeah, good. So that's a complete graph. So what did we use for our window? You want to write down those values. That was 0. So your min and max, min and max. And that's all they asked us to do, find complete graphs. Okay, so we did that. Okay. Where these two things cross, okay, if I go back to it, that's the break-even point. If you can find the spot where your cost to make the product is equal to the amount of money you brought in, well, now you've broke even. Okay? So if you have a graph like we do, we kind of already answered this, where is the break-even point visually in that picture? It's where what happens? Yeah, it's where they cross. So where is this point? It's the intersection. Okay, so it's the intersection. So let's take a look and see if we can answer this. Find the number of shirts that the company has to sell to break even. So algebraically, all you have to do is solve this equation if you wanted to do it with algebra. Take our formula for cost, which was, I think it was it 1.5 for every shirt they sell? Was that the cost? Yeah. Plus 200,000 equals, and the revenue, I think they sold them for $4 each. If you can solve that, which I'll leave that to you, that'll give you your answer. Or, graphically, we're just going to calculate an intercept. So second, calc, intersect. Tell it which two graphs you want to use, but there's only two. So blue, red, bless you. And the guess, you can get it close, but it doesn't really matter. Okay, so let's take a look at what we've got right here. So how many shirts do they have to sell to break even? Yeah, Emily? 80,000. Yep. So that's how many shirts they have to sell to break even. What will their cost be to make 80,000 shirts? Yeah. Kaya? 320,000. Yeah. So 320,000 is the cost to make 80,000 shirts. What's the revenue if they sell 80,000 shirts? Yeah. 320,000. Yeah. The break-even point is when the cost and revenue come out exactly the same. So now every shirt they sell beyond 80,000, now they're making money. Okay. Any questions on that? So that's a break-even point. That was really the last thing that was in section 2.2. All right. So section 2.3. Title says pretty much what we're doing. We're looking at solving linear and quadratic equations algebraically. So we're not going to use graphic calculator as much here. We did a little bit with break even, but we won't need it as much here. Okay, so first of all, just basic definition, what is an equation? Anytime you basically have an equal sign. Okay, that's an equation. And usually when you put in the equal sign, there's an expression on the left, like that. There's an expression on the right. Could be something like that. And you solve it. So an equation is when you put an equal sign between two expressions. If you use x in the equation, like I did, we can say that we have an equation in the variable x. Usually that's kind of weird. We don't say that a lot, but that's what it basically means. You have an equation in x. Or if I said to you to write an equation in k. But this is a fancy way of saying use k as the variable for whatever the problem is about. Okay. Again, if you know this, you don't have to write that, but when you solve an equation, it means to find all the values that make it true. So if you had something like 2x equals 12, it says solve, you're finding the value of x that if you plug it back in, makes it true. So you're trying to make this the same as the right side. So if you let x equal 6, that would work. Now, some equations are a little different because they're always true. And that's an identity. The equation I have on the board, you can plug in any number you want for x and it's always true. The easy way to see it is to do out what's on the right-hand side. If you distribute and then combine like terms, look at what's on the left. 3x plus 2. Look what's on the right. 3x plus 2. Whenever you have two things like that that are equal to each other and they're the same, that's an identity. It means you can plug in any number for x and it's always true. So the way we write the answer to a problem like this, all reals. That would be the answer to that problem. Some people write true. Well, yes, it's a true statement, but what does that mean? It means that anything is an answer to it. And if you're still not sure, you're like, well, why is anything an answer? Just subtract 3x from both sides and look what happens. 2 equals 2. That's a true statement. Okay. A conditional equation, that's an equation that could be true if you pick the right value for x. So like 2x equals 10. There's a condition to make that one true. You've got to pick the right number. Okay. So these are just two different types of equations. Okay, to check your equation, or to check your solution to an equation, you just plug it in and see if you get a true statement. Okay, it's even doing that kind of stuff since Algebra 1. You really don't need to write that down. But we'll do an example right here. Okay, you might not know how to get -2. I think on the calculator, you should be able to graph that and calculate a root. But algebraically, I don't think anybody would know how to solve that. Because it's a cubic. Can't use quadratic formula on something like that. So they just want you to check that -2 is a solution. Right? So Tori, how do I check that -2 is a solution?
You plug it in for x.
Plug it in for x. So -2 cubed minus -2 plus 6 equals 0. Okay, -2 cubed gives me -8. Minus -2 becomes +2. Sometimes I put a question mark above it because we don't know if it's true yet. That's what we're trying to figure out. And Gabe, what's -8 plus 2?
-6.
And then plus 6.
0.
Perfect. 0 equals 0. Is that true? Does 0 equal 0? Yeah. So we got a true statement. that means -2 is a solution, and we just verified it. Okay. That's how you check if a number is a solution. All right, so linear equations, if you get it equal to 0, would have this form. ax plus b. Sometimes you see it in like algebra 1 as y equals mx plus b. That's the same. So ax plus b equals 0. A and b can be any real number you want. That's what that's saying. A and b are elements of the real numbers, except a can't be 0. What would happen if you made a 0? Oh, Jared?
It would just be b equals 0.
Yeah, you'd wipe this right out. And now you have what's called a constant equation. That's like y equals 2 or y equals 6. There's no x in it at all. So if you do that, you've created a constant equation. For a linear equation, you've got to have an x in it somewhere. Okay, so a and b, anything you want, except a is not 0. All right, we'll solve that real quick. Shouldn't take too long to go through that. Kaylee, what would I have to do on the left-hand side to start to solve that?
Distribute the 2.
Okay, so I'll do that. What else?
And then distribute the 3.
All right. All right, so we do that first. Gabe, what would I do next on the left?
Combine my terms.
Yeah, so I see a 4x and a 3x.
Set next.
Good. And a -6 and a 3.
-3.
-3. Now we want to get all the x's on one side, so we can just subtract the 5x to the other side. Add the 3. Okay, and Madison, my last step would be to
Divide 5 by 2.
divide 5 by 2 and 2 by 2. Divide everything by 2. So you get x equals 5/2. Okay? So that's a lot more complicated than just an equation like 2x equals 10, but it's still linear. And if you're like, well, it doesn't look like that at all. Yeah, it does. If you go to this last step, I could write this as 2x minus 5 equals 0. Something times x minus a number equals 0. So even though it started out kind of complicated, it turned into something that was linear all along. Questions on that? Okay, absolute value equation. Sometimes people forget how to solve these, but the idea is you always get, or most of the time, you get 2 answers. And the way you get it is to split the equation into 2 parts after you isolate the absolute value expression. Okay, so I'm just going to hit next so you can see one that's isolated, but I'll come right back to it. Maybe it's down here. Yeah. That has an absolute value expression that's isolated. It's just an absolute value on the left-hand side, nothing else. That does not have an absolute value expression that's isolated. You have to move the times 10 to the other side by dividing by 10 first. Same thing if I did this. Absolute value is not by itself. I would minus 6 from each side first. So that's what I mean by the first step. Isolate the absolute value, and then we're going to split it into 2 problems. The first problem is the same as the original. You literally just erase the absolute value bars. That's it. So the first one is the same as the original. We just take out the absolute value bars. The second one, well, we start off the same, but we got to do one extra thing. You're going to write the second equation. You're going to erase the absolute value bars, but you're also going to change the sign of the number on the other side. Okay, that's what negate means. Negate is the opposite. So change the sign of the number on the other side. And what I mean by that is you're always going to have a number by itself on one side, like 5 in this case. Can you have variables on the other side? Yeah, but I might have you try one in the homework, but as far as like a test, we're just going to stick with numbers on the other side. Okay, so let's see if we can split this into two problems. First equation, same as the original, except without absolute value bars. So someone think they could give me the first equation? Yeah.
2x plus 3 equals 5.
There you go. 2x plus 3 equals 5. Perfect. Okay. And now, how about the second equation? Yeah.
2x plus 3 equals negative 5.
2x plus 3 equals negative 5. Any questions on that? And we always put the word and between them because they're both solutions. So I'm going to get x equals 1 if I solve the one on the right, and x equals, what would that be, negative 8 divided by 2, negative 4. Okay, so you just solve each one. So x equals 1 and x equals negative 4. Okay, any questions on that? So that's the key. Just remember, when you have absolute value, you've got to split it into two problems because there's always two solutions. Now, if you had something like this, a lot of people start solving that. They say, okay, I'll just split it into two problems. Why? What would happen here? Does anyone see what's happening there? Yep, Rob?
Never mind.
Look at what you have there. You have absolute value equals negative 8. Yep.
Absolute value can't equal negative.
An absolute value never equals a negative. So you can do the whole procedure here, and you'll get two answers, but they won't work at all. Okay, they won't work. You can't solve a problem like that. But just because it has a negative on the other side, don't assume it's always not solvable, because what if you had something like negative 10 plus? You say, oh, number on the other side's negative, can't solve it. How come this one you could do, though? Yeah?
So you add 10 to negative 8, you get positive 2.
Exactly, because you got to get the absolute value by itself first. And if you do that, now it's equal to 2. Now you're good. Now you can solve it. Okay? So keep that in mind too. Absolute value equals a negative. You can't solve it, but it has to be isolated, not like I had below. Okay, so mixture problems. So the idea of a mixture problem is you're taking two things and mixing them together to make something new. So we might have like a solution that's measured in percent. So we might have, say, a 5% solution of cleaner and a 10% solution. And I'd say to you, I want you to mix them together. So you have a 6% solution of cleaner. And I want you to make 100 gallons of it. How much of the 5% and how much of the 10% would you mix together to make what I just said? That's basically what we're looking at. So these are the two equations. One equation involves the total amount. So like when you mix the two together, how much stuff do you want to have? 100 gallons, 20 liters, okay, how much? The second equation has to do with concentration. So it's a concentration, which is always as a decimal. So if they give you something like 5%, you want to make it 0.05. So all of them, all decimals. So you have a concentration of the first liquid times how much of it you use, plus the concentration of the second liquid times how much of it you use. And then it's going to equal the final concentration, which they'll give you in the word problem, times the total amount of liquid they want you to make. Because it's a system of equations, you're going to end up using substitution to solve it. I mean, I know there's other ways, like elimination, but substitution is the easiest. You don't have to do the substitution in your head. I'll just show you how to do it out. Okay, so let's just set up our equations, and then we'll pause there. Does everyone have those two written down? Okay. So in our problem, we have two solutions. A 10% solution and then a 25% solution. Okay, so maybe that's like the strength of the cleaner. Sometimes if you look at like hydrogen peroxide, it says on the bottle 3% hydrogen peroxide, 97% of it is water. If you actually put like 100% hydrogen peroxide on your skin, it would burn right through. It's not good. Same thing with rubbing alcohol. You can buy rubbing alcohol and it says like 70% isopropyl alcohol. Sometimes it's like 91%. So it's different percents. So I want to mix these together. So we have 15 liters, and I want it to be a 12% solution. So it's kind of somewhere in the middle, closer to 10. Okay, how much of each solution do we need? Okay, so let's just pick the variables for those, and then we'll pause with that. So we don't know how much of the 10% solution we need. So what could I pick as a variable? Jake? Sure, you could pick X. So we're going to use X liters of the 10%, and then the 25%, we don't know that either, so what can we pick for that one?
Y.
Sure, we'll pick X and Y. So when we come back, we'll set up those two equations using those two variables. All right, so now let's start with this one. Amount 1 plus amount 2 equals total amount. So we said we're going to use X liters of, I didn't call them amounts 1 and 2. Okay, here they're kind of like A and B, but same idea. So Tori, how many liters are we using for the first solution?
X liters.
Yep. And how many for the second? Y. We know that when we mix the two solutions together, I want to end up with 15 liters. Okay, so that's my first equation. Second equation. It's all concentration times amount plus concentration times amount equals concentration times amount. So let's start with our first concentration as a decimal. Renee, what's my concentration of the first solution?
0.1.
Yep, 10% or 0.1. Yep. So concentration is 10% times how much of that solution are we going to use? X. So concentration times amount plus, Haley, what's my concentration for the second solution?
0.25.
0.25 times how much of that solution we're going to use equals, and then take your final concentration times your final amount. My final concentration is 12%. My final amount is 15. So that one we can do it. 0.12 times 15 is 1.8. So when I write that equation again in the future, I'll just put 1 point. Okay, so now we've got two equations with two variables, and we're going to use substitution. Which equation here, we'll call them 1 and 2. Which equation is easier to get a letter by itself in? Equation 1 or 2? 1, yeah. Which letter? I'd say it's either way. But equation 1 is definitely the easier one to get a letter by itself. So how about Joe? What letter do you want to get by itself in equation 1?
X, I guess.
All right. So using that equation, what would x equal?
Negative y plus 15.
Negative y plus 15, or you could also do
15 minus y.
Yeah, it's the same thing. 15 minus y. So that's your formula for x, 15 minus y. And now, we're going to plug it in right there. So we're just going to do substitution. So we got 0.10, or really you could just do 0.1, it's the same thing, times x, but now you're going to change x to 15 minus y. And then everything else stays the same. Now if you look at the equation, there's only one letter in it. So this equation is basically, well, it's kind of similar to when we did this one. A little bit of distributive property and combine like terms. And that's it. So let's see what we got. 0.1 times 15 gives me how much? 1.5 minus 0.1. If you want to put 0.10, that's fine. Minus 0.1y. All right. You got some like terms. Negative 0.1 plus 0.25. What's that going to give me? If it was negative 0.01, it would be 0.24. 0.15. Yep. So 1.5 plus, make sure we did that right, 0.15 equals 1.8. Subtract the 1.5 to the other side, and that would leave me with what on the right? Yep, again, 0.3. So the number's actually working out nice where I thought we were going to need a calculator for all the decimals, but I don't really think you need one. What's 0.3 divided by 0.15? 2. So I'm going to be using 2 liters of the 25% solution. So I'll just put y equals 2 liters. And how many liters of the 10%? 13, because the total is 13. Yeah, if it was a little more complicated and you couldn't do that part in your head, just go back to one of your equations, fill in the one you found, find the one you're still missing. Any questions on that? So there'll be a mixture problem pretty similar to that on the test. But that's the idea every time. Set up the 2 equations, and then I always use substitution, and then solve from there. All right, let's see what else we got. Quadratic equations. Okay, so quadratics, we've already looked at solving a little bit. I'm not sure why they kind of come back to it again at this section, but that's the form of a quadratic, ax squared plus bx plus c. Again, a, b, and c can be anything you want except a can't equal 0. If you make a 0, you wipe that right out. And if you wipe that out, bx plus c would basically be what? It wouldn't be quadratic. What would it be? Yeah, it would be linear. So if you make the first term disappear, you turn it into linear. So you can't let a be 0, but a could be anything other than 0. Okay, one way to solve a quadratic equation is to factor. So let's try an example where we have to factor. So the point of this isn't really to teach you how to factor. I'm kind of hoping from Algebra 1 you remember, at least it'll come back to you how to do it. But that's what I'm just trying to do, just refresh how to do it. Okay, so when you're factoring, this one's already done for you, but you always want to get it equal to 0. You always want to get it equal to 0. This one already is. Next thing, you want to put 2 sets of parentheses. Now, we have to figure out what my first term is going to be. Since it's 2x squared, you don't have any choices. What's my first term going to be here and then here? Yeah. 2x and x. Where it gets a little more complicated is if that number was like a 12x squared. Now you could try like 4 and 3 or 6 and 2. You got options. But with 2, it's a prime number. So there are no options. Now my signs. I have a negative constant and a positive middle. Does anyone know what my signs have to be in the parentheses? Yeah? Plus, minus? Yeah, it could be minus plus. We don't know until we put the numbers in here. But it is one of each. And now 2 numbers that multiply to give me 3. Just 1 and 3. So I'll just try it in the order someone said and see if it works. So I get 2x squared. And then I get minus 6x plus 1. Well, minus 6 plus 1 is minus 5. Is that what I wanted? No, I wanted plus 5. Since the number is right and the sign is wrong, just change the signs. Now I get 2 times 3 is 6. Negative 1 times x, that's my negative 1. 6 minus 1, there's my 5. Okay, so now I've factored it. And what do I do with each of those factors now? Yeah, because if you're multiplying 2 things together and getting 0, either this comes out to 0, or this comes out to 0, or both. One or the other has to be 0. So in this case, you get x equals a half. In this case, x equals negative 3. They are both solutions. Any questions on that one? So that one was nice because it factored. If factoring doesn't work, you can use the quadratic formula. Again, I think most people already know it, so if you know that, you don't have to write it down. If you don't remember it, it would be a good idea. The quadratic formula is negative b plus or minus your square root of b squared minus 4ac. And we've seen the b squared minus 4ac other times. That's the discriminant. And all of that is divided by 2a. Remember, when you're using that formula, if you're wondering where the a, the b, and the c come from, they come from setting it equal to 0. So you've got to get the equation looking like that first. It's got to be equal to 0, just like when you factor. Does everyone have the formula that needs to write? Okay. So, let's just try an example. 2x squared plus 2x equals 1. Yeah?
Minus 1.
Yep, I'm going to minus the 1. Now, what I usually do off to the side is I just write down what a, b, and c are so I don't forget. So Ashley, what's a in this case?
2.
The 2. And b?
2.
2. And c?
1. Negative 1.
Negative 1. Yeah, just fill a, b, and c into that formula. So we've got negative b plus or minus the square root of b squared 4ac all over 2a. Now, what I usually do here, because I see minus a minus, if you subtract a negative number, what's going to happen? Yeah. Yeah, I know once I multiply all that out that's in that box, that's going to be a negative number. So if I subtract the negative, it's going to turn positive. So I just make it positive right away. If I simplify what's under the root, what do I get? Well, Blake? Oh, yeah, it would help if Blake was here. Joe. Still getting my names. 12, yeah. 4 times 2 is 8. Times 1 is still 8. 8 plus 4 is 12. Divide by 4. And now, with the square root of 12, how does the square root of 12 simplify? Yeah. And it's good once you write it as 2 square root of 3, because look what happens. You can divide everything by 2. Divide by 2, 2, 2. Just the stuff on the outside of roots. Okay, but if you do it in one spot, you got to do it in all 3. So the final answer is -1 plus or minus square root 3 over 2. Any question on it? Just kind of a quick review of quadratic equation. And okay, let's look at this one. This will be our last one. So we did okay. A little faster than I wanted to go, but I think a lot of that was review. Except maybe calculating a break-even point. But I think we did intersections before too. So this problem says that you're going to cut squares with a side length of x, or a side length of 5 inches from each corner. So basically what you're doing is you're kind of making a little tray. So you're cutting out a corner of like a rectangular piece of paper, and then you're going to fold the sides up to make sides, and you're going to have a little tray with sides on it. No top. So the sides that you cut out are 5 inches by 5 inches. Find the width and the length of the piece of cardboard. Okay, so let's see if we can set this up. Now, they got to tell us something else. Like, they got to tell us maybe the volume of the tray or something. And one thing they tell us is that when you fold it, the length is twice the width. Okay, so that's important. Length is twice the width. And the volume of this is 2,040 cubic inches. Okay. Find the dimensions of the cardboard. Not the dimensions when you fold it, just the original piece of cardboard. So they're telling us something about volume, so we need the formula for the volume of a rectangular prism. Basically like a cube. What's the formula for the volume of a rectangular prism? Yeah. Okay, so let's start with that. Volume equals length times width times height. Now, they tell us something about our length in relation to the width. What do they tell us about the length? Yeah. It's twice the width. So let's just write that down off to the side. The length is twice the width. Now, let's see if we can write the formula for the length times the width times the height of my folded tray. So the original length from here to here is L. But you're cutting out corners. So anyone think they could tell me how long that is? Yeah. It's going to be L minus 10. So L minus 10. And how about the width? It's kind of the same idea. That's my width, yeah.
W minus 10.
Yeah, it's going to be W minus 10. So we have the length when we fold it, the width, and now the height. What's going to be the height of the sides on the tray when you fold them up? Yeah, it's 5. So this isn't bad, except for the fact there's 2 variables. Now, V isn't really a variable because we know the volume is 2040. How can we get rid of the L or the W? You've got to get rid of one of them and change it into an L or a W. So you only have one variable. Yeah.
You can change the L to 2W.
Exactly. They tell us the length is twice the width. So now, 2W minus 10, W minus 10, and 5. And what I would do, this is kind of a little trick, is I would factor 2 out of that first one to write it as W minus 5. And now I've got 2 numbers I can multiply. What's 2 times 5? 10. So you can divide each side by 10. So what that's really going to do is this. You don't have to do that, but it's just a little trick and it makes everything a lot easier to work with. So 2 times 5 is 10. Divide each side by 10. Now you have this. And if you FOIL that out, you get W squared minus 10W minus 5W plus 50. Now you've got a quadratic equation. Right? And we just practiced solving a quadratic. Might not come out to a nice answer, but once you get it equal to 0, you could try factoring it, or just use the quadratic formula. So we can finish that tomorrow if we need to, but it's really not that bad from this step. Okay, so homework, it's mostly page 96. Page 89 is a break-even problem. So it's like find the cost, find the revenue, make a graph, find the intersection. I think those are the 4 problems there. And then page 96, just some practice with solving equations. Some factoring, some quadratic formula, and maybe one or 2 word problems at the end. So we'll go over that tomorrow. I'll be here for extra help on Thursday this week, and this is our last test before progress reports close for the term.